Down is towards the center of Earth, bro. What do you think this is? Which direction do you think is down for Wee Todd? He's French. His parents thought it would be funny to name him Yes Todd. What does Wee Todd have for down? Where's his down at? Where's his down at? The center, right? That's what you're saying. It's the center of Earth. So the nothingness explosion that created infinite, ever-expanding nothingness, and this spherical Earth that is majority water, but somehow can contain water, curved water on the exterior of a sphere, which no one's ever seen curved water before, because the law of physics is that water always finds its level. At rest, water is level. There is no curve to water. So on the exterior of your curving, spinning, revolving, rotating sphere, okay, which defies all laws of physics, just like the law of entropy that in the very beginning, so nothingness exploded and created something. No explosion ever created anything ever. All explosions destroy. So your nothingness, explosion of nothingness, created something. How does that make any fucking sense? That's almost as dumb as saying laying a bar magnet flat on a table using an instrument that only works flat and then incorrectly using it means a globe with two poles. You don't tell the fucking compass needle. The compass needle tells you. So the compass needle is telling us that is north. Direct observation of two people on this globe shows us that down is the center according to the globe. Sure, bro, fine, whatever. But that means he's upside down. So now let's take a comet, okay? So let's say that there's an asteroid or whatever, and it's coming across, all right? Now, at the top here, we all in the northern hemisphere see that go from across the sky, from downwards, okay? It's coming down across the sky. But if it passes, once it passes the equator to Wee Todd, the comet would be rising from the horizon. And that never happens. The stars in the compass, navigation, like every objective measure of reality, it's the conclusion of all objective measures, all of them. This T level is like 3 out of the 6 basic instruments of an airplane, called the 6-pack. When you fly a plane, it stays level flight, cruising level altitude, okay? Flying across. So we go from here to here, and we go down. Now on the globe, if we want to go visit Wee Todd, we start here, which is flat and level. Then we take our elevation, and we get our altitude. Now, we have to, if we don't constantly nose down, let me get it level and show you. If we don't constantly nose down on the globe, we will end up out of space. So on a globe, on your airplane, you would have to compensate for this curvature. If we lived on a globe, pilots would have to compensate a full mile every 2 minutes, traveling 500 miles per hour. And that never happens. So you think it's raining upside down in Australia? You think trees grow upside down in Australia? You think there's curved water on the exterior of a sphere and not held in a vessel like a puddle, like everyday life that you see every fucking day? Like every single day of your life, you see water in a container because water has to be contained. It must be in a vessel. It's always rest flat. The Nile River is beyond evident that the earth is flat and not a globe. The stars, every instrument, the compass, sextant, astrolabe, star maps in general. If this is a never-ending expanding nothingness, the stars would change. They wouldn't be fixed. The South Pole star is not a fixed pole star. It rises and sets. It cannot be seen by everyone at the same time. The North Pole star never rises, never sets. It's fixed in its position, and all constellations that revolve around it can be seen by everyone at the same time on this northern hemisphere meridians.
Here's Lake Victoria. It drains down into the Mediterranean Sea. It's 1,135 meters high, so it's about 3/4 of a mile high, and it's 4,200 miles long. So it goes from 3/4 mile high to to 4,200 miles. Okay, let's check out the Nile River on a globe. So here's Lake Victoria. It flows north all the way to the Mediterranean Sea. So it goes from here to here. So let's check it out from the side view. Okay, here's a little mock-up of the Nile River. To make it accurate on a globe like this, it needs to be 0.08 of an inch thick. But for demonstration purposes, we'll just make it something I can actually hold in my hand. So let's lay it down across like that. And let me show you the top view. Okay, we're back to the side view. All right, the Nile River travels north from Lake Victoria to the Mediterranean Sea. It zigzags 4,200 miles, but it travels 2,400 miles. Okay, let's do the math. Here's Google Earth. You can see it travels 2,348 miles. Let's check out the Earth curvature calculator. We're going to type in a 0 viewing height and then the distance of 2,348 miles, just like Google Earth says. And our Earth curvature is 3,399,986 feet. Not bad. Now we take our Earth curvature in feet, divided by 5,280, and we get miles, 643 miles. Now we divide it by 2, and we get 321 miles. Okay, back to the side view. Okay, so the Nile River, if you lay it flat on the globe, it would be a 300 and some mile hump in the middle. That's higher than the International Space Station. Obviously, it can't go over this hump, the 300-mile hump, because gravity goes this way, right? Gravity doesn't go this way. It goes down this way. By the way, gravity is not a downward force. It's a bending of space-time. Just like you guys are going to bend what the hell I'm saying after this video. I make this video. Let's do another example. Here's this ship, right? Downward force. It doesn't blow the ship right off the planet, does it? Obviously, it can't go over a 300-mile hump. So, let's flatten it out like the topographical profile. Okay, we flatten out the Nile River. The Nile River only pitches 1 mile down. So, in fact, the last 1,000 miles of the Nile River only pitches 100 feet. So basically, we're going to lay our Nile River on top of the globe. And you can see it's floating up in the air on each end 300 miles. Do you know of anything that sticks up on the Earth 300 miles? I don't think so. Higher than a space shuttle? No. All right, so now let's pitch it so it actually drains into the Mediterranean Sea. Okay, that's awesome. Uh-oh. The one side is up like an inch. An inch on this globe is like more than 1,000 miles up. I don't think there's any mountains that are 1,000 miles high on the Earth anywhere. All right, so now if we lay it down flat, let's say we're going to shove it into the globe. And let's see what happens. Okay, here's our soft globe. See, it's sticking up 300 miles. All right, let's shove it into the globe. If we shove it into the globe and make it level where it pitches this way a mile, it's going to fill up with water. So that's out. I really don't see how this model can work. Okay, here's my model. It's a scientific fact that water seeks its own level. That makes all the oceans flat. So here's Lake Victoria, and it drains down into the Mediterranean Sea, right there. So let's place our little mock-up river on here. And we're basically going to pitch it 3/4 of a mile. Piece of cake. Obviously, if you survey it, it's going to be 3/4 of a mile higher on this side, and it's going to pitch down to the Mediterranean Sea. 3/4 of a mile.